The Marines were attempting to build a personnel carrier that could approach a shore at a speed of 40 knots while in the water, but reality intrudes. What they're expecting to do is unrealistic. In order to have enough armor plate for it to be a useful personnel carrier, there is a surface to volume area that needs to be accounted for in the design of the actual armored vehicle. That, however, means that if you have a vehicle which has adequate armor plate, it would sink. The only way to actually achieve it is to separate it into two pieces. Build an armored carrier with enough armor plate to be useful, and then build an additional device which would have the engines needed for propulsion and additional flotation around the vehicle which can be detached. To travel at a speed of 40 knots, there is a requirement to have about 100 horsepower per ton. For a vehicle as long as the Marine carriers, the length of the vehicle is useful in terms of traveling through waves because you have the steepness of the wave. A longer vehicle has less of an angular motion going up and down the waves, gives a better ride, and is safer when operating through higher waves and higher sea states. That would mean that the vehicle would probably have to weigh about 50 tons. The Army M2 Bradley personnel carrier weighs about 37 tons. The longer vehicle would weigh about 50 tons. In addition, you have the additional flotation device, which is going to weigh probably an additional 20 tons. That comes out to a total of 70 tons, including fuel. That would mean you need about 7,000 horsepower. A Black Hawk helicopter uses about 6,000 horsepower, a little bit under that. So you need to have two engines that are bigger than the engines put into a Black Hawk to achieve the 40 knots. When it arrives on the beach, it would travel on its tracks. It would detach the flotation device with the gas turbine engines and drop it onto the beach. Underneath the flotation device would be bumpers, so that when it drops onto the ground, there is less damage to it, and hopefully no damage to it. The armored vehicle will then have to reverse out of it, drive around it, and then move forward. In order to reattach the flotation device to the carrier, cables would be run from the carrier onto the top part of the flotation device at its front and would be then winched in. The carrier would drive up and have contact with the inner surface of the flotation device, which would be shaped to fit over the front end of the carrier. The cables would then be winched up and the flotation device raised up into full contact with the front of the vehicle. Additional cables would be attached at the sides. They would also be winched up and raise it into position. Trunnions, pins would come out of the sides in the upper part of the carrier and would work as stops to bring it up and hold it into position. Additional pins would then be run through holes in the flotation device to lock it into position. The holes would be lined with plastic to prevent metal-on-metal contact, which causes stress concentrations. The Marines then have a vehicle which can travel at 40 knots in the water, approach beaches, and be useful as a military vehicle. The one big problem is it takes up a lot of deck space. As far as that goes, the reason why a Marine vessel is their current size is to get through the Panama Canal. So the maximum vessel width is about 108 feet. They are building bigger locks in the Panama Canal, which means the Marines can build a bigger landing vessel, and these carriers can then be placed on the bigger ships, which can then carry enough personnel and equipment and still travel through the bigger locks in the Panama Canal, as opposed to having to reduce them to place them on the current Marine amphibious warfare ships. Once the main flotation device is detached, it might be possible to have roll-up raft sections which are stored between the upper and lower portions of the track. They would be rolled out and inflated and would then enable the carrier to travel across rivers, streams, and smaller bodies of water. There is some choice in how to set the vehicle up. The relative position of the turret to the main body of the vehicle. The back part of the vehicle needs to be somewhat higher because the personnel on board have to be able to stand in order to exit the vehicle efficiently. If that height is carried forward, you get a relatively higher vehicle. If you use a lower deck in front, the turret can be lowered. If the driver's compartment and the engine compartment can be lowered, or the turret as well can be dropped down to a slightly lower level, which gives you a slightly lower vehicle. That, however, does provide less flotation volume as an amphibious vehicle. The cables that are used to lift up the flotation part of the vehicle also help to hold it in place at the top of the vehicle. The pins would then be moved into position into matching holes in the flotation device, and that entirety of the pins and the cables should maintain a fairly rigid structure that will not shift under wave action. When using the flotation device and traveling through the ocean, the carrier will have to be steered and controlled from the upper turret. The vehicle commander will actually have to be driving the boat until it makes contact with the shore. The flotation devices would either have to be collected from the beach, or personnel would have to be assigned to protect them until they are removed and reused.